You've been walking past the most valuable signal in the creek because it looks like ordinary, ugly black gravel. Most beginners see this dark sediment and move on to find a prettier spot with clear water and white sand. But if you know how to read the river sorting table, that patch of dark sand could mean thousands in gold. You are literally stepping over the river's own gold signal because you haven't yet learned how to listen to what the water is telling you. The truth is that nature sorts minerals by weight, shape, and flow, acting as a massive, built-in conveyor belt that never stops. If you can read the patterns left by this machine, you will see what everyone else misses, which is the exact difference between walking home empty-handed and finding a pocket that changes your entire year. You need to stop looking for gold and start looking for the traps the river has already set for you. The problem most prospectors face is that they treat the entire stream as a single unit, but the river is actually a sophisticated sorting machine that works on a geological time scale. Gold starts its life inside hard rock veins, often dozens of miles uphill from where you are standing. Over thousands of years, weathering breaks that rock apart, and water carries the free gold downhill, depositing it only when the current loses enough energy to drop it. Because gold is an element with a specific gravity of 19.3 when pure, it is nearly 20 times denser than water, and significantly heavier than almost every other mineral in the streambed. However, the river does not sort by weight alone. It sorts by settling velocity. This leads us to the revelation of hydraulic equivalence. While gold is nearly 4 times heavier than magnetite, the primary component of black sand, the gold grains found in placer environments are usually much smaller than the surrounding black sand grains. These smaller gold grains have less settling resistance, which balances out their higher density. This means that wherever the current drops to a specific critical velocity, both the tiny gold flakes and the larger black sand grains will drop out of the flow together, as hydraulic twins. This is why every professional placer miner checks for black sand first. It is the river's own signal flag that a high-energy drop zone has been reached. To find the gold, you must locate the 4 primary hydraulic traps where this sorting happens. The first and most reliable trap is the inside bend of the river. Physics dictates that water flows faster on the outside of a curve and slower on the inside. Centrifugal force pushes the main current toward the far bank, turning the inside curve into a slack water zone where heavy minerals can no longer stay suspended. You should look for those big piles of cobbles and heavy, black shiny stones that appear as the current slows down. When you kneel on an inside bend and scoop up gravel that looks ordinary, you are often working a pay streak where the river has already winnowed away the lighter material for you. The second trap you need to master is the eddy pocket, which is found directly downstream of a large boulder or obstruction. A massive boulder kills the forward momentum of the water and creates a near-zero velocity zone in its wake. After a flood event, you will find black sand and gold packed tight in that pocket, protected from the main flow of the stream. In some cases, the black sand behind a boulder can be so thick it looks like an oil slick on top of the gravel. You should visualize the creek during high water and realize that these obstructions act like natural riffles in a sluice box, forcing the heavy gold to drop out immediately. The third and perhaps richest trap involves bedrock cracks and crevices. Bedrock serves as the natural settling floor of the river, and once gold reaches it, it cannot go any deeper. The water velocity inside a narrow crack is essentially zero, and once heavy minerals settle in, they are locked down and shielded from the current. You will often need specialty tools, like a screwdriver or a crowbar, to pry open these cracks because the gold and black sand are wedged in so tightly you might need tweezers or a snuffer bottle to pull them out. These are the most localized and concentrated deposits you will ever find, often holding gold that has been sitting there for centuries. The fourth trap is the leading edge of a gravel bar where the channel suddenly widens or the bed rises abruptly. In these areas, the current effectively drops off a cliff, and the heavy minerals lose their suspension and drop at the bar's upstream face. After a heavy rain, the river often resets itself, and you can see a fresh layer of black sand right at that leading edge. You should treat these areas as nature's own sluice box, but remember that you must dig down as deep as possible to reach the impervious zones where the gold has worked its way through the lighter alluvium. To confirm you found a productive trap, you must perform a field test on the black sand itself. You can use an $8 neodymium magnet to drag through the wet concentrate. If the sand clings hard to the magnet, you have magnetite, which is your primary gold signal. You should also carry an unglazed porcelain tile to check the streak of the minerals. A black streak confirms magnetite from igneous rocks like basalt, while a red-brown streak indicates hematite, telling you the iron chemistry and pointing you toward the upstream source. While high concentrations of magnetite are a necessary condition for finding gold, they are not an absolute guarantee. The United States Geological Survey notes that you can find high magnetite with no gold, but you will almost never find gold without the associated black sands. The skill lies in knowing when to stop and when to dig. If you work a double handful of gravel through your pan and end up with a thick black layer coating the bottom after 3 minutes, you are standing on the river sorting table. You must then use a 10x jeweler's loupe to examine the heavy mineral layer for fine placer gold, which will appear as bright yellow, unmistakable metallic flakes sitting in the black matrix. These flakes catch the light differently than mica or pyrite, which are often confused with gold by beginners. Mica is platy and light enough to float away when you swirl the water, while real gold will stick to the bottom of your pan. You are a detective on the river, and your job is to triangulation the source of the gold by observing if the pieces get larger, coarser, or more angular as you move upstream. If you find gold in a trap, and then it suddenly stops further up the creek, you know you are close to the source or a tributary that is feeding the main channel. This process of sampling is not a one-day deal. It can take weeks or months to find the richest locations. But once you find that honey hole that hasn't been worked, you transition from a prospector to a miner. You must be patient because bad weather or an unlucky spot can result in a zero gold day even on a productive creek. But the next trap 20 feet away might hold 2 grams of flake. The river has already done the hard work of sorting the gold for you. Your only job is to learn how to read the signs it left behind and work with the physics of the water rather than against it. If you can do that, you will stop chasing shadows and start finding the gold that most people walk right past every single day.